So the next thing I did was started looking into water science. And I was specifically looking for confirmation of the mechanism that I envisioned, you know, this notion that H2O polarity was variable, and that that hydrogen bonds were the mechanism that caused that variation, that caused that polarity to go up and down. Specifically, you know, hydrogen bonds neutralize the polarity. And I actually expected to find it. I expected that this was something that was well understood, and that it was maybe a little bit obscure, but if I was to look hard enough, I would find evidence that substantiated it. But it turns out, not the case. Not the case. I didn't find anything that would suggest, or no one explicitly indicated that any kind of mechanism like this was possible. Now, being a person who is naturally kind of cynical of authority, which I guess in a sense, which is what originally got me to suspect that meteorologists really didn't know what they were talking about in the atmosphere, and since my research confirmed that, I felt, you know, pretty confident about that. I also suspected, hey, maybe these water researchers really don't, well, maybe they just missed something. Maybe they missed something. So I started looking into polarity, and I kind of already mentioned part of it, which has to do with what they call electronegativity differences. Let me explain that a little bit more explicitly. Now, electronegativity difference, here's a water molecule. It just simply says that this oxygen molecule is more massive, and it pulls down electrons onto this molecule here, and you know, making these more positive and this more negative. But a lot of molecules have this ability, and they aren't all polar molecules. And let me give you a perfect example, and that's the methane molecule. It's very similar to the water molecule because it has covalently bonded hydrogen bonds, or covalent bonds with hydrogen atoms. Now, what's different though about the carbon or the methane molecule is that it is not it's not a polar molecule because of the fact that these are all arranged symmetrically. Now, part of the limitations when it comes to explaining something like this is the fact that you have a two-dimensional piece of paper here. In reality, this is a four-dimensional thing, and it involves what they call a tetrahedron. If you were to twist two of these molecules like this, you would see that this is actually a tetrahedron that goes like that. And there's a tetrahedron, you can think of it being a three-sided pyramid with a bottom. It has four corners and four sides, and each one of the corners of the tetrahedron on the methane molecule is filled with a hydrogen atom. Now, the water molecule also has that same underlying template, which is based on what they call the steric number, and there's a whole theory about this called Vesper theory. I suggest looking that up if you're interested in understanding how electrons are arranged in the outer valence shell of the molecules that make up most of our environment, things like oxygen, carbon, nitrogen, those kind of things. Now, with oxygen, a little bit more of a massive molecule, so it attracts more electrons naturally, and here are the two, what they call non-bonding pairs of electrons for the water molecule. And again, if we were to really imagine these things, it would be more of a tetrahedron like this. You would twist these like this. But this is a polar molecule because of the fact that it can't really form covalent bonds down here, whereas this one can, methane can form covalent bonds on all four corners. It therefore is not a polar bond or a polar molecule, a dipole. Now, I started asking myself, though, some rhetorical questions. I said, what if, kind of a thought experiment, I said, what if we were to remove the two hydrogen atoms off of this, artificially in some way? Wouldn't this turn into a polar molecule? And then I took that a step further, and I thought, what if these things were actually movable? We can envision the polarity in here actually changing, going up and down. And I took that a step further and I says, well, what about the if that'll do that here on the on the methane molecule, the carbon atom, why wouldn't it do the same thing with oxygen on the water molecule? And why would it even matter whether the bonds that formed down here were covalent or not? As I thought about it, it really wouldn't matter. It wouldn't make any difference at all, because it has to do with what's happening to the electrons on here. And the electrons don't know the difference between a covalent bond and a hydrogen bond. And so that kind of answered the questions. You can think of it this way. As hydrogen bonds are formed in water, they neutralize the polarity. So if there's two bonds here, two other H2O molecules come up and form a hydrogen bond right here, the polarity here on this molecule is going to be 0. And if there's 1, the polarity is going to be 2. Which, if you remember, gets right to what we were discussing previously. Zero, 4, 2. And the concept that it all comes down to, and this is the thing I think the people in water sciences missed, is that they may have understood electronegativity differences, and they may have even understood the fact that symmetry, it's hard to believe they don't have some understanding of this being asymmetrical and this being symmetrical, and that being the underlying cause of the H2O polarity. But here's the thing I think they didn't quite take into account. Symmetry is not a constant, it's a variable depending on the degree to which hydrogen bonds are formed. And that answers the question. That tells us why H2O has such unusual behavior in the atmosphere, and of course in all contexts, and why it has, well, let's go over that again. It has the high boiling point. It has the high boiling point because it has that high polarity when it's on an individual basis. It's passive anytime it's in a liquid form. By that I mean its polarity has been neutralized. And that helps us understand another kind of quirkiness of H2O, and that is why it is so fluid. See, when this is 0, these things just kind of float here, these hydrogen bonds. And as they pull away, the polarity would start to return, so they could never quite get away. H2O is in a sense kind of it's a pseudo gas and it's a pseudo liquid, because the more it becomes a liquid by creating a bond here and coming together, the more it zeroes this out, which allows it to float away again. So water really does have kind of a dual personality, and it all comes down to the fact that H2O polarity, or the polarity, is variable. And this is maybe, I think, the most interesting one of all, especially with respect to understanding the possibility that there's any kind of a plasma going on in our atmosphere, and that might explain some of the phenomena like tornadoes and jet streams and such. And since this does allow for a more electromagnetically active and a harder bond, we can now have a mechanism to understand how, when surface area of water in the atmosphere of liquid water is maximized, it produces a more electromagnetically active entity, explaining the underlying basis of the plasma.